This is a video from section 7.7, and we're going to look at an example from the lecture notes. How large do we have to choose n so that the trapezoidal rule and midpoint rule approximation for the integral from 1 to 2 of e to the 1 over x dx is accurate to within 0.0001? All right. So what I'm going to do is I'm going to let f of x equal e to the 1 over x. F prime of x is equal to negative 1 over x squared e to the 1 over x. And remember, that's just chain rule. Do not forget that the derivative of 1 over x with respect to x is negative 1 over x squared. Okay? Now, take the second derivative, and I thought maybe it would be a bit easier to apply the product rule. So I took the derivative of negative 1 over x squared and got 2 over x cubed. And then I multiplied by e to the 1 over x. Then I'm going to go minus 1 over x squared times the derivative of e to the 1 over x, and the derivative of e to the 1 over x is e to the 1 over x times negative 1 over x squared. Now notice how I have an e to the 1 over x common to both terms. I'm going to factor that out, and so I have e to the 1 over x times the quantity 2 over x cubed plus 1 over x to the fourth. Now, what I want to do from here is I want to bound the absolute value of f double prime of x. Now, the absolute value of f double prime of x is equal to e to the 1 over x times 2 over x cubed plus 1 over x to the fourth. If I make the denominator for 1 over x smaller, 1 over x gets bigger. Okay? Now remember, x is less than or equal to 2 and greater than or equal to 1. So 1 over x, if I take the reciprocal, is less than or equal to 1, but it has to be greater than or equal to a half. And so this is going to be less than or equal to e to the first times. Now look at the first term. Make the denominator smaller. Then the fraction will get bigger. So this is 2 plus 1. And I claim that's 3e. And so I'm going to choose k to equal 3e. Now, come over to here. E sub t is the error in the trapezoidal rule. Okay? E sub m is the error in the midpoint rule. So we have E sub t is the error in the trapezoidal rule. E sub m is the error in the midpoint rule. So let's have a little reminder here. E sub t is less than or equal to, and it's the absolute value of that, is k times b minus a to the third divided by 12n squared. And then the absolute value of E sub m is less than or equal to k times b minus a cubed divided by 24n squared. Now, let's go back. We want this integral accurate to within 0.0001. 0.0001. And we want to find the n that makes that happen. Okay? Now, let's go back here. Oh, let's come over here. Now, A is 1. B is 2. K is 3E. Okay? There are other choices we can have. Okay? Now, let's take a look at the trapezoidal rule. We're going to take one at a time. So I'm going to set 3e times 2 minus 1 to the third, right? Now, let's go back. I'm going to divide by 12n squared. And I'm going to set this less than or equal to 0.0001. Solve for n. Okay. Now, 3 goes into 12 4 times. And so I'm going to get e over 4n squared is less than or equal to 0.0001. Now, I claim n squared and 0.0001 can switch places. And so n squared is greater than or equal to, okay, e over 4 times 0.0001. And so n is greater than or equal to the square root of this. So it's e over 0.00, that's a point, 04. And what is that approximately? So if we get out a calculator, okay, so I'm going to take e divided by 0.0004. And then I'm going to take the square root of that. And this is approximately 82.44. And so I need a value of n that works. And what you can do is you can choose n to be 83. And then you're guaranteed for that choice of n that the error bound will be within 0.0001. Because the logic is, if this value is within 0.0001, then most certainly this will be within 0.0001. And I claim I'm going to do the same thing for the midpoint rule. Okay? So for the midpoint rule, so I'm going to set 3e times 2 minus 1 cubed divided by, should be 24n squared, right? That's for the midpoint rule. And that's less than or equal to 0.0001. 3 goes into 24 8 times. So I get e over 8n squared is less than or equal to 0.0001. And so n squared is greater than or equal to e divided by 8 times 0.0001. And so n is greater than or equal to the square root of all that, right? Now, the question is, what is that approximately? Well, you could either take 8 times 0.0001 or 0.0008 or whatever it is, right? And so I'm going to take e divided by 0.0001 equals, divided by 8 equals. And then I'm going to take the square root of that, and I'm going to get an answer. The answer is approximately 58.3. And so I can choose n to be 59, something just a little bit bigger. Remember, n is a natural number. So that's the basic idea. Could I have chosen n to be 60? Yes. Could I have chosen n to be 75? Yes. As long as you're bigger than 58.3, it works. Because, again, if we go back to the rule, right? See, notice, if this is within 0.0001, so is this. So the error will be within that too. Okay, that'll conclude this video from section 7.7, and we looked at the example from the lecture notes. Thank you.